Welcome everyone to our 2020 Tectonics modeling tutorial. I will start this with a few introductory slides, and afterwards I will hand it over to our speakers for the first day. But first of all, I will share my screen and show a few introductory slides. So this is CIG's 2020 Tectonics modeling tutorial. It's great that you are all here, that we have such a huge interest in the meeting. As I already said, originally we had planned this as a very much in-person event with a lot of interactions. Now we have much more people than we originally expected. We will make the best out of that and try to make this as useful as possible. This meeting was organized with a lot of support by CIG, the computational infrastructure for geodynamics, and in particular by John Naliberth and Lorraine Wang, who are here today as well. But this tutorial will be partly given by a lot of different people, and they are all here today, this morning. And we thought it would be nice if we can't make an introductory round for everyone because we're too many, but if at least the presenters could quickly introduce themselves with the names and maybe the institution. And afterwards, I will continue with some words about the logistics of this meeting. So I will just go first because I'm speaking anyway. My name is René Gassmüller. I'm a project scientist with CIG and soon a visiting assistant professor at the University of Florida. And I will speak tomorrow on a different topic. Today's speakers are Wolfgang Bangerth and Timo Heister, and maybe they can go next in introducing themselves.
Sure. I'm Wolfgang Bangerth. I'm a professor of mathematics and geosciences at Colorado State in the central part of the United States. And I look forward to telling you a little bit more about Aspect in 10 minutes or so.
And I'm the second person who is doing the first tutorial today, partly doing it. My name is Timo Heister, and I'm an associate professor also in mathematics. And I'm at Clemson University, and it's in South Carolina in the US. And yeah, hope to get to know you today.
Okay, so as I said, I will speak tomorrow. And on Wednesday, there will be John Naliberth and Anne Glaram. Do you want to introduce yourself?
Go ahead, Anne.
So hello, everybody. I'm Anne. I am a postdoctoral researcher at GFZ in Germany. And I will be speaking on Wednesday and Thursday.
Yeah. Good morning, everyone. I'm John Naliberth. I'm a research scientist at CIG, and I'll be starting as an assistant professor at New Mexico Tech in August, and I'll be speaking on Tuesday and Wednesday.
Okay, and that leaves Julian Denberg on Thursday and Menno Freitas on Friday.
Yeah, hi everyone, I'm Julian Denberg. I'm an assistant professor at the University of Florida in geological sciences, and I will talk on Thursday about magma transport.
And I'm Menno Freitas. I'm a postdoc in California, in Davis, at UC Davis, and I will talk on Friday.
Okay, thank you all. Next, I will talk a bit about the logistics about this meeting, how we will handle things.
But before you do this, I think we should also let Lorraine introduce herself.
Oh, I'm sorry. Yes, Lorraine. I only went through the days. You're the organizational mind behind all of this.
Yeah, I get to enjoy the experience and watch all of you speak and not have to actually give a presentation myself, which is just wonderful. And I thank everybody for all their hard work for putting this together, and all of you, especially in the various time zones, for making it today. My name is Lorraine Wang. I am the director of CIG. My background is actually as a seismologist, and when I'm not doing my day job, I also work on small projects in rescuing historic seismograms and open source science software. and science.
Thank you. So now let's talk a bit about the logistics of this meeting. I already said that we had originally planned this meeting as an in-person experience, but given current events, that's not possible, which is, of course, a bit sad, but on the other hand, it also provides an unusual advantage because all of you can much more easily join in this meeting. So this meeting will be fully virtual. There's no in-person component. And we will be using Zoom for the presentations. And since you are all in this Zoom meeting, I guess that you have found the instructions for how to join. During the meetings, because we have so many participants, please remember to always mute yourself unless you are speaking at the moment. If you have questions about the current presentation, then please type your questions in the chat. We will try to monitor the chat and either reply directly to the questions, or if they are relevant for all participants, then we will interrupt the current speaker to ask them to explain this in more detail. As you have probably noticed already, these presentations will be recorded and we will make them available online so that you can recapitulate the content or also share them to others who didn't have the time or couldn't join this meeting today. All the materials that we will discuss during the meeting are available on our webpage on geodynamics.org. You can also directly reach the meeting page of this tutorial under bit.ly/aspect-tutorial. And finally, by participating in this meeting, you agree to the code of conduct that CIG has set for itself, which essentially means that we want this meeting to be an inclusive meeting, an inclusive event. We don't want anyone to do any kind of discrimination based on any properties in this meeting. We want this to be a positive experience for everyone. So please follow this code of conduct and essentially just be supportive of other participants in this meeting. The goals that we would like to achieve during this meeting are, first of all, a quick introduction into geodynamic modeling, but we assume that you already know some things about geodynamic modeling. We want to, in particular, talk about applying geodynamic modeling to tectonics problems. And since we use Aspect, the modeling code Aspect, as a tool for how to solve these problems, this is also an opportunity to learn more about Aspect and how to set up models in Aspect. And finally, we would like this to be an opportunity to meet other modelers, make some connections, maybe get help with some problems that you might have, or provide help to others, just get to know other people. The agenda for these meetings will be more or less like this every day. So we will have presentations between 7 a.m. and 10 a.m. in Pacific time, which you will have to translate to your local time. Each day will introduce a different topic and will usually involve building some model, running the model on your local machine, and then discussing the properties of that model and maybe modifying the model. All of the presentations will be online. Many of them already are, and they will be updated over the week. You can reach them under the link that's currently on the screen, bit.ly/aspect-tutorial-slides. And the models will also be available, but this will be discussed in the first tutorial today as well. After the official presentations are over, we had planned to have some discussion groups. These groups are meant for you to ask questions if you maybe haven't completely understood something in the presentations, or if you want to play around with the models of this day or with the concepts of this day and discuss that with others. these are completely voluntary. So if you are only here to see the tutorial about how you would do something in Aspect, then you don't need to participate in the discussion groups. But if you are here to use Aspect further after the tutorial, or if you have a specific project that you want to work on, then it's likely useful if you stick around, and we will form these little groups so that you can help each other, and we will also be available to help in these groups. Outside of these time slots, there are also ways to communicate. So first of all, you can always ask questions in our forum, which you can reach under community.geodynamics.org. We will monitor the forum and answer questions there. And finally, there is also a separate Zoom meeting, which will be open during the whole tutorial under the link that I posted here. And you don't need to write that down because you can reach these slides through the tutorial webpage on geodynamics.org. This separate Zoom room is there so that you can talk to other participants of the tutorial if you have questions. It's password protected. The password is here on screen. And this is more a free-form discussion group that runs throughout all of the tutorial. And finally, originally we had planned to have some one-on-one meetings with everyone who is interested in modeling a certain topic or to create a certain model setup. And we had hoped to talk with you directly about this and how to set that up. Since we now have so many participants and this is a fully virtual meeting, it's harder to organize this part. But if you want help on a specific topic, then please put up your name and your email address in a Google spreadsheet that we prepared. You can reach that under this link that I just showed here. So bit.ly/aspect tutorial help. And we will try to set up meetings about certain topics with maintainers so that we can help you directly with some questions or with a certain model setup. We will have to figure out how to do this exactly, but we will try to make it happen. This is about the amount of information that I wanted to give initially before we hand over to the first topic. If there are any questions about the logistics part of the meeting, then please raise your hand or type the question into the chat and we can discuss them at this point.
Yes, please note that you do have a lot of buttons at the bottom of your participant panels. There's the yes or no if a question is asked, and there's go slower, go faster. You can also raise your hands as well.
And in case you missed the links that Rene posted in his slides, Lorraine was so nice to post them in the chat, but also when you signed up to this workshop, there's the workshop website. And if you scroll down, there are links to the slides and the models that we are going to use during this.
Okay. I didn't see any specific questions at this point. If you have any later, then feel free to type them in the chat and we will reply to them. And then I would hand over the screen to Wolfgang for the first part of the tutorial, I think. Or is it Timo?
To me.
Okay. Then please share your screen.
All right. First, welcome from me too. It's I think we're all excited that there are so many people from around the world, and it's you know, when you run these workshops, usually you anticipate the people from the country that you're in come and maybe a few others, and it's fun to see that there are people from Morocco and from China and from India and from Brazil and from all of these other places, and I think that's really fantastic. So I'm excited about this. Okay, so let me share my screen. And let's get started. So share screen. Here we go. Okay, can you all see that?
Yes.
Very good. Okay, so Timo was too much here. The presenter studies today is going to monitor the chat window. So if you have questions, please type them into the chat window, and then he can interrupt me. And, we can talk about this. So what I want to talk about is sort of the basics of this code aspect that we've been developing for the last 9 or 10 years, and give you sort of an idea of how do you describe models in Aspect. Today, maybe not necessarily with a focus on tectonics modeling, but sort of just give you the basic outline of this code. So originally, actually, let me ask you this: do you see the window with faces on the right? Does that obscure anything?
Yep, that's in the way.
Okay, so how do I close this?
There should be a thing that looks like a little dash you can click to minimize.
I just move it out of the way. Yeah, I think that will do too. Okay, so yeah, so originally the code got its name from the advanced solver for problems in Earth's convection, and you get the idea already that it was meant as a mantle convection code. That's what we really wanted to do, is simulate the deep Earth between the core mantle and the crust, and that the mantle convection problem, of course, is a much different problem than what we're here together today for the tectonics modeling. Namely, it is fundamentally a viscous flow problem. It's a rather complicated fluid, if you think about it, if you try to describe it, but it is fundamentally a fluid flow problem. But over the years, we found that we can extend Aspect into areas that also are relevant to tectonics modeling. In particular, we added models that have elastic properties, that have plastic properties. So these are parts of the description of how tectonic plates behave, for example. And then we also added melting, free surface, and other things that have to do with what you would need to describe tectonics models. And you will hear about many of these pieces over the course of this week. So just to show you a few examples of what Aspect is being used for. So for this original mantle convection part, we were thinking of describing the Earth, or we describe the Earth, for example, as a shell between the core mantle boundary and the crust, in which you have these sort of plumes that rise up. So these sort of places where hot material rises up from the core mantle boundary, and then you have, of course, places where cold material dips down. So this would be subduction processes. And the background of this code is that it was written originally by people who had an interest in numerical methods. So one of the things that you see on the right is that we have adaptive meshes that are fine, that have high resolution in areas where something is happening, and low resolution in areas where nothing is happening, so that we can keep the computational effort at a reasonable level, and we can simulate much more complicated processes this way. But then I mentioned that Aspect is also used for tectonics problems today, and so here's the slide that I have from John Naliboff, who I'm sure is going to talk about similar things later this week. That corresponds to a problem where you have extension. So you can think of this as the crust that you pull from the left and from the right, and the material in the middle breaks and then deforms in viscoplastic ways. And as a matter of fact, as I'm looking out of my window here, I'm sitting above a plane in a rental house this week. It's a rift valley. I'm looking out onto a rift valley, which is, of course, exactly what is being shown here in this slide. Similarly, if you want to deal with tectonics problems, one of the things that is quite relevant is melting of material. And that's something that Julianne is going to talk about later this week. So you see here an example of a plume that rises up and produces melting like in giant igneous provinces, so large igneous provinces. So that is also something that is now part of Aspect. So it is not only about convection anymore, but Aspect can simulate many other things. What's behind Aspect is sort of the philosophy that we adopted when we started this code, and that we have stuck to over the years as we develop it. So it is a code that is intended to incorporate all of the modern numerical methods. We have roots in the mathematical finite element community, and so one of the things that we wanted always to do is to use the best numerical methods that we have today, and that includes, for example, adaptive mesh refinement. I showed you an example of this where the mesh is fine in certain areas and large in other areas. We have very good linear and nonlinear solvers. We have higher order discretizations and stabilization schemes. So the idea is that we really want to make good use of all of the computational resources that we use. It's a code that's intended to be usable and extendable by not just the original authors, but we wanted to make it available for a whole community. So it comes, for example, with a very large manual. And it comes with a lot of cookbooks and examples. So if you look at the manual, there are, I don't know, maybe 100 or 200 pages where we explain how to set up certain situations. Right, and the idea, of course, is if you write a code for the community, you realize that you really need to document how to use this code, or every person of the community will have to ask you personally, how do I do this, how do I do that? And that doesn't scale. If you want to have a large community, you have to provide documentation. And we've really put a lot of effort into documenting how you can set up many different examples or many different situations. And this is all encoded in these cookbooks and the examples that are in the manual. It's a code that runs in parallel. I don't quite remember what the largest computations are that we have done, but it's probably on the order of 10,000 or more processors now. Actually thinking about it, maybe 100,000 or more processors. So it is really intended to solve very large, very complicated problems. And the last part is it is built on others' work. We have made the conscious decision that as a community of developers of this code, we cannot provide all of the functionality that we need to address these modern numerical methods ourselves. We need to build on what other people have done. So in particular, we're built on a library that is called Trilinos for the linear solvers. We built on a library called pforest that deals with the parallel distribution of a mesh. And we built on a library called DL2 that describes all of the finite element functionality. And that really has allowed us to leverage all of the work that is being done in these other libraries. So in particular, these libraries are well tested. We don't need to write and debug the code ourselves. The Aspect code itself is much, much smaller than it would be if we had to do all of these things ourselves. And then, of course, if, let's say, DL2 improves its functionality or makes it faster, we get all of these things in Aspect as well. So that's a conscious decision that we gain by building on other people's work. Aspect is a community code, and I'm going to tell you a couple of things about how it came about. So it was always intended as a community code from the beginning. It was licensed under the GNU public license. It is developed in the open on GitHub, so you can see every day what has changed in the previous day. It is a code where we encourage contributions. We want you to participate in this project, not just by using the software, but also by contributing your own improvements, and that might be very small. So yesterday I submitted a patch, for example, that added 2 characters in the documentation string, because I think, well, the documentation became more readable this way. There are other patches that add commas. So these are things that we appreciate, but of course, in the end, hopefully, you will learn how to become proficient in this code and also contribute much larger patches. So how do we get to this sort of model? So the origin of this code date back to 2011 when Timo Heister and me, Timo sitting on the left, me on the right, both with more hair than, well, I don't know, I have more hair than I have right now. We started this code when we were both at Texas A&M. And then over the years, we sort of accumulated more and more people who work with it. So the next folks who joined were Julianne Danberg and Renee Gassmann, who are also going to present this week. So they're in the middle here in this picture. But today, the code really is a community code. It is developed in communities. So there are 8 principal developers. Over the years, more than 60 people have contributed to the code. And a very substantial part of the development happens during what we call hackathons. These are meetings where, well, at least in the past, when we could do this, we would lock up 25 or so people in a house somewhere in the middle of nowhere. And then we would spend 10 days just developing this code as a group. Everybody would work on whatever they find interesting and whatever is necessary for their work. And then it gets integrated into the development versions of Aspect that then become the next release. So I tell you this because I hope that some of you will find this sort of development model interesting and that you too want to be part of these 60+ contributors, or maybe eventually want to become one of the principal developers of Aspect. And that is really something that we try very hard to encourage, that everybody is very welcome in this community to contribute, that we like it this way. We do not feel protective of our code. It is not our style to say, well, but this is what we want. But if you think that you have functionality that might be interesting to somebody else, then it should go into Aspect. And I hope that that is one of the things that you take away from this week, that we're all very approachable and that we very much like people like you all to contribute to this code. Okay, so some of the resources I've already mentioned. So if you need to look something up, the canonical source is always to go to aspect.geodynamics.org, hosted like everything else by CIG. So geodynamics.org is the website of the computational infrastructure for geodynamics. I should also mention in this context that a substantial fraction of the development of Aspect is actually financed also by CIG. So at this website, you will also find links to the manual, for example. I'm going to show you an example of how this manual looks like later. And then other things that you can find there is, so there are 2 key publications that describe sort of the methods behind Aspect that are listed here. And then you can also find links to on the order of 70 publications that use Aspect. So if you're interested in finding out, does Aspect support what I want to do, that would be a good place to start, right? If you can find other publications that use something like what you want to do, then clearly it's possible. It might also be a way for you to contact other people who have done similar things, and maybe they're interested in collaborating with you. Okay, so having given you this, this introduction, let me talk a little bit about how you use Aspect, how this works in practice. Actually, thinking about it, now Timo is going to talk about this, and so I think this would be the place where I stop sharing, and maybe Timo takes over.
Oh, and I was hoping that I don't have to do anything today because you just keep going.
You can do it either way, but I think we should give you credit where credit is due.
All right, so I will just keep going where Wolfgang just left off. And Wolfgang, it would be good if you could monitor the chat if there's other questions or comments about this. And I hope my window is mostly out of the way. Actually, I can go full screen. Okay, so I will give a very short introduction on how you actually use and run Aspect. And I will not only show you the slides, but I will actually go through it live, exactly how it would look like on your computer. So let's get started. A little bit of high-level overview. Aspect is a program that runs on mostly Linux machines, and it is a command line tool, right? So it is a program that is driven by input, and it generates output, and then it exits. There's no graphical user interface or buttons to click. And the simulation that you actually run, or the model, is controlled by a text-based input file. We call them parameter files. They typically have the extension .prn. And you can edit them in a text editor, and there you specify what kind of model you want to run. For more, that's what we're going to do today. And for more complicated things, if you need to implement something that is not already there, that is not something you can combine with from existing features, you need to write code. And if you need to write code, these are typically done using plugins. So we will go over this mostly tomorrow as an introduction in more detail. But the idea is that if there is something that works similar to some already existing geometry, for example, then you write a small plugin that just implements this, and you don't have to dig into the main Aspect code to do that. The outputs that are generated, again, I will show this in a second, is, among other things, a statistics file that we're going to look at that basically records statistics during the simulation. For example, for each time step, there's going to be an entry, and you'll see how big was the time step, what are other statistics like solver iterations, and et cetera, et cetera. And then we generate output files that allow you to visualize the simulations. And we also generate other output files as needed, and depending on what you selected in your input parameters. So that's quite flexible, and there's a lot of things there that I'm not going to show today, but that you might discover over while you learn how to use Aspect. The installation of Aspect is somewhat complicated. It's difficult. The more powerful a scientific code is, generally, the more difficult is it to get to install it. And we have installation instructions in the manual, if you're curious. But what we're going to use today for demonstrations, what I'm going to use to show it to you, is we have a pre-packaged virtual machine using the freely available VirtualBox software. And this one you can install in Linux, Mac, and Windows. And you import the virtual machine, and that contains an image of an Ubuntu Linux distribution where all the dependencies are already installed, and it will look the same on each of the computers, on my screen, on your screen, etc. And I hope you already downloaded the virtual machine, otherwise you will be waiting for the download to finish. This is really good for demonstrations and to first play with Aspect, but as soon as you want to work seriously with it, I would recommend that you install it natively under your machine. It's more difficult, and we don't want to do that today. Okay, so this is the high-level overview of how Aspect works. And I will now quickly go through the slides, and then actually, instead of going over this in detail here, we'll show you how I do it on my computer instead. So you install VirtualBox. I hope you did this already. You import the virtual machine that you also hopefully downloaded. And it is available at this URL. I create these virtual machine and update it regularly on this website with newest versions of all the dependencies. And it's called the DEAL2 virtual machine because it's mainly done to contain DEAL2, which is the finite element library that sits below Aspect. One important thing to do is that you choose appropriate number of cores and RAM depending on how powerful your machine is. If you choose too much RAM or too many cores, then your computer might hang or it might run very slowly. I will show this in a second, but you can find it under machine preferences. After you've imported it, which I hope you already did, then you have a virtual machine that you can start by hitting the start button. It might not look exactly like this depending on your VirtualBox version, but roughly you should be able to find a start button. And I will show this in a second. And then if you boot it up, this is roughly how it looks like. It opens up a browser window, and the browser window shows a README file by default that tells you what it is, what is installed, and what you can do with this machine. And it again reminds you of setting the number of cores and the amount of RAM that you have. And one more thing that is probably important is if you do not have an English US keyboard layout, for example, if you're in Europe and you have a European layout, the layout won't really work. And so what you need to do is to click on Start, Settings, Keyboard, and then instead of using the system defaults, you would add your own keyboard layout. And I hope you can find the setting. If not, it will be difficult to type in the things that you have to type in. So before I do the demonstration of actually running Aspect, let me go through the steps. Not all the steps, because I already imported the machine. So this here, I hope you can see this. This is VirtualBox, the main VirtualBox window. This is the DL2 virtual machine, and I can click on settings here, for example. And this is the settings for the virtual machine. And under system, you can set how much RAM, and under processors, you can set how many cores you have. My machine has 4 cores, 8 with hyperthreading, but I just use 2 for now. Actually, you can change this to 4 if I want. And the most important thing is that you have around at least 4 gigabytes of RAM to be able to compile and run things, but less than what you have in your machine. So this is the setup that I have here. I don't think you have to change anything else. One thing that you might want to do is set up a shared folder if you want to copy files in and out, but I'm not going to show you that right now. Instead, I'm just going to start this, and then we see how it works. So you might need to maximize the window for this to work, but you should see when you click Start that there's a virtual machine booting up. So this is a Linux distribution booting up. And I'll wait a few seconds for it to start. And this is how it looks like. So now you can see that I'm running inside this window with the red title frame. I am running, and let me try to get rid of this. I am running this virtual machine, right? And in this virtual machine, I also have a web browser to access the internet and to download things as needed. And again, for the keyboard layout, Start, Settings, Keyboard, Layout, then you uncheck your system defaults, and then you can add a different keyboard layout if you need to. I'm not going to do that right now because I have a US-based keyboard. Okay, that is the very basics on getting the virtual machine to work. And inside this virtual machine, which is a normal Linux machine, you have access to Aspect and all the dependencies, and also editors, programs to visualize things, etc., etc. And you can also install other software inside this virtual machine. Okay. I will pause for a second in case there are questions at this time. I hope there's not too many issues in getting to this point, and I hope you did these steps already before we started. But just in case, I will quickly look at if there's anything. So the only question I see there is the amount of RAM. Something in the order to 5 gigabytes should be enough to compile everything, and it should be less than what you have in your machine. At least 1 gigabyte less, depending on what other stuff you're running outside the machine. There's nothing you need to do regarding USB. If you want to do more advanced things, I have not used USB devices inside the machine. The only thing I do is shared folders. Okay, so what I'm going to show you now is how you run simulations. So like I mentioned earlier, the Aspect is controlled by parameter files. And in our example, we are going to run a tutorial.prm that I'm going to share with you in a second. The models are available under this link, or they are also available when you click on the sign up website under models, or the link that Renee gave you under models, they all link to the same thing. There's a repository where all the parameter files are in there, and I also have instructions in there. So let me actually show you by clicking on this link. Hopefully it works. So this is the repository. So this is it's on GitHub, where we also do our development, and it is hosted by Renee. So this is Renee's repository. It's called Aspect Tutorials. And if you go there, there's different folders for different tutorials. There's only this one right now here, right? So this is the current tutorial. And then here's the material for the different days and the different sessions. We are obviously on day 1. And all the commands that I'm going to type in today are actually listed here, so you can copy and paste things as needed, and you don't need to copy from the slides or figure out. And here's also the tutorial PRM file that we will have inside the virtual machine in a second. Okay. The parameter file, and we go about this again in a second, set all the settings for the model run that you would like to do. And what I'm going to show you, and what I want you to be able to do, is to run Aspect from the command line with this tutorial PRM file, and then you look how the parameter file looks like, and then we can also visualize the result. And that is what I'm going to do now. So what I'm going to do is I'm going to clone this repository inside the virtual machine. And this will create a folder that I will show you in a second that is basically a copy of the thing that I just showed you in the web browser. And again, these instructions are available in under the models link that you already know. And then let me just go into the virtual machine instead of showing you the slides here. And then we were going to run Aspect. Aspect is installed in this directory, and we just run it with the name of the PRM file. And I'm going to show you that in a second. So let me go back into the virtual machine. So what I'm going to do is I'm going to open up a terminal. You can do Control-Shift-T, or you can click on the little black terminal button here. And I'm going to increase the font size in the hope that you can see better what I'm going to type. And what I'm also going to do is I'm going to open a file browser. That's the third button, File Manager.
Timo, I'm going to pause you here for a second. It's Control-Alt-T, just so that nobody gets confused.
Yep, Control-Alt-T, yeah.
Or the little terminal button in the top.
Thank you.
Row.
Anything else at this point before I continue?
I think we're good.
Okay. So this is the home directory when you click on the file manager, and you see there's a folder with Aspect where Aspect is already installed, and there's also other things installed under libs. There are libraries, there's DL2 installed, etc., right? But it's relatively empty. So what I'm going to do is I'm going to go here, and what I'm going to do is I'm going to, this is not good full screen, just going to show it here. I'm going to type in this command to clone this repository here. And I'm actually not going to type it in, I'm just going to copy and paste. So it is git clone, and then this address. And then I hit return. And it takes a while because we have added a lot of files over time. So it's a little bit slower than it was when I tried it out. And so you see on the right here is the file manager, and you see that a new folder appeared, which is called Aspect Tutorials, right? And then inside it, there's a README, and there's the folder for the current tutorial. And inside you find the folders for the different sessions. And again, we're on day 1, so we're going to day 1. And this is where we want to be, right? So this is the folder that we want to be in, the directory where we want to run things in, and here's the tutorial PRM. And in the terminal, I can also go there using CD, Aspect Tutorials, and I'm using tab to autocomplete because I don't want to type everything. And now I'm in the folder day 1, and you can see here that there's the README and that there's the tutorial PRM, right? Okay, and so to run, let me go back to the presentation. So what we did was we did the clone. We moved into this directory. And what I'm going to do next is that I'm going to run Aspect. And so Aspect is in the home directory, in the folder Aspect, and the binary that we run is called Aspect. And as the one parameter, we give it the name of the PRM file that is in the current folder. So let me just do that. So if I run aspect, and again, I use tab to autocomplete. If I just run aspect, what it will tell me, it will run, and it's not really readable like this. So let me try to make this big for a second. If I run it like this, it will say, hey, this is aspect. Please tell me with a parameter file what you want to run, right? And that's what I'm going to do. So there's a tutorial PRM in the same folder, so I can run it like this. Right, so aspect, this is the binary of the compiled version of aspect, and I'm running it in the current folder in the day one folder. And I hit return, and then it will run, and it will output a lot of information. And this is an example that runs quite fast. It does a lot of time steps. I can't even read what it's saying, but it will take a couple of seconds to complete, so 20 to 30 seconds, depending on your machine. And we can look at the output later on, so don't worry if it's too fast to scroll by, but this is where we're at. Okay, and so it says that the run is complete. And this is the output that I get at the end. And so now let me show you what happened by moving the terminal again to the side and showing you the folder that we ran this program in. And notice that there's a new folder that appeared. That's the output folder. And inside this output folder, there's a bunch of files of interest. And of special interest for us right now are 3 or 4 of these files. So log.txt is a text file that contains the output that scrolled by a minute ago very quickly. Statistics is a statistics file that contains statistics per time step that is human readable, but it's also machine readable. We'll talk about this in a minute. And there's TVD files. These are actually for visualization. And there's other files that I'm not going to talk about today. So let me just show you the log.txt. You can double click here, or if you're in the terminal, you can use xdg open. That's the same as double clicking. So the output / log.txt file. If you do that, the same thing happens and this window opens up. And here you can see that the simulation is running, right? And it took 22 seconds to run. And we did 119 time steps. And here are some statistics that you can see. For example, temperature, averages, min, max, heat flux, and other statistics about the runtime. So this is the log.txt, and you have that after your run completes. Okay, back to the slides. Here I actually show how you open it up using LeafPad. LeafPad is actually the editor that I used, so you could have done LeafPad log.txt, and the same thing appears. Okay, so now we ran our first simulation, right? So if I have a different PRM file, I can rerun aspect with a different PRM file. If I edit the PRM file, I can run it again, and it will overwrite the results and generate the outputs for me. Okay, I will stop for a second here and ask, before I talk about visualization, I will ask if there are any urgent things I need to cover or explain. Some of my Zoom window totally disappeared.
So we didn't had any questions about the cloning or running aspect part so far, and I summarized the commands in the chat window for everyone. We have one comment that the model is running more than a few minutes, but as Wolfgang just wrote, this depends on your machine. So it can be slow, it can be fast, depending on your laptop. Although it should definitely not run longer than, let's say, 5 minutes or so.
Yeah, it might be that your machine settings are not good. You forgot to plug in your laptop and it runs on battery, or you're doing something else on your machine. So you can see whether you're running out of memory. Okay. So let me continue. What I'm going to do now is...
Can you quickly repeat the part about the XDG open
Yes.
part?
So if you don't want to worry about this, I showed you that there's a file manager, right? And you can just double click on this file to open it. That's perfectly valid to do. But you can use, so xdg open is a Linux command that says, pretend that you're double clicking the file and use the most appropriate program to open it. Or in this case, the simple text editor that is installed here is called LeafPad. So this is this text editor. And you can open, with this, you can open files. So I can, for example, also open the tutorial PRM. So LeafPad space tutorial PRM return opens the editor here. And this is the PRM file we're going to look at in a minute that controls the setup and the simulation that we're actually running.
And so it really doesn't matter whether you double click on it in
Yes.
the file browser or whether you use LeafPad or you use this XDG open command.
Yep. Or if you have preference for a different editor, you can install it and use that. This is just the default. Okay. So now I'm going to show you how to visualize the results. And the slides contain detailed information about how to do this with ParaView. I should mention that that's not the only way to visualize things. Visit is another tool that can open these files that is also installed in the virtual machine. And Wolfgang is probably happy to tell you about that at some other point outside this tutorial. But I'm going to show you how to use ParaView in the next couple slides, next couple minutes. And it has a lot of features and a lot of options. And I'm not going to show you all of these, obviously. But most of us use this for the graphical output, for the inspection, for generating results, for inspecting them using ParaView. ParaView is installed, so I will show you how to do that. And the important parts of ParaView are that I should mention that are not obvious is there's the 2D and 3D view, which is the big large window where you see your output. And there is this list that is empty at the beginning, which is the pipeline browser. And that's what the name is. Here you see the files that you opened. You can open more than one file at a time. And you can see filters that you apply to a file. So for example, you open up a 3D solution and then you generate a slice through the 3D solution that produces a 2D solution. Or you generate a contour, or you generate streamlines, et cetera, et cetera. They will all appear there and you can modify them by clicking on them. And when you click on one of these items at the bottom here, are the settings in the object inspector where you can change settings. And of course, up there are toolbars, but I don't have to tell you that. So let me just show you that instead of showing you the slides. So I'm in here, and I guess I could run ParaView by typing in ParaView. I think I also have, I don't have a button here, but it might actually be installed here. Yeah, so if you type in ParaView, you can also launch it like this. There's many different ways how to do it. And so this is the ParaView window. It looks very similar to the screenshot, and we'll work with this in a second. Just let me show you. You could also, I closed it again, and I just run it by typing in ParaView. The one disadvantage here is that now my terminal is blocked, and so maybe I don't want to do that. I can put it in the background. I don't have to tell you how to do that. I guess it's easier if you start it using the start button. So this is how ParaView looks like. And what we need to do next is we need to open the file that is the output, and that is the solution.pvd file that is inside your output folder. And if you open this file, then we can look at the solution that we just produced. And again, there's many ways to do it. You can do file open, you can click the open button, or you can right click open. That's what I normally do. The easiest is probably to click to do file open. That's easiest to find. And then you might not be in this directory yet, but you might be somewhere in your home directory. And then you need to navigate to Aspect Tutorials 2020 Day 1 output. And here you can find the solution PVD file. Let me click on that, okay. And nothing happened except that there's now a solution PVD in the pipeline browser. But if I hit apply, the button that is highlighted in green, you see an unhelpful gray box. And we will talk about how to actually show the solution in a second. Before I go there, I would like to show you one other way to open the file more quickly. So I will close this. And when I'm here in this day 1 folder, right, where I ran a minute ago, I can go paraview output solution.pvd. Let me maximize this window. I hope you can see that. And it opens up automatically having the solution PVD loaded like this. And if I hit apply again, this is how it looks like. You probably are getting a warning message that I put here to the side. You can just close that or clear it and remove it. Or I moved it to the bottom here. It's sadly because it's running in a virtual machine and I haven't changed the default to not show this one. Okay, so I did already load the file in, but we are not seeing anything yet, right? So let me quickly go back to the slides. We did already this step, right? We clicked open and we navigated to this folder and we opened up the solution PVD. And now what we can do is that we can, let me go back to the virtual machine, is that you can change how it's being visualized. And there's a drop-down menu at the top that says solid color, which is the gray solid color, which is not super helpful. Here you can pick what variable you want to look at. And the first variable that we're going to look at is the temperature T. And this is how it looks like when you do this. This is the box that we ran the simulation in. And you see the color shading for the temperature. We seem to have a temperature of 3,600 at the bottom and 270 something at the top. So it's hot at the bottom, cold at the top. And you can move around, you can drag the solution, you can zoom in with your mouse wheel, and you can also obviously change to show other quantities. For example, you can show the density, the pressure, and other quantities. The other thing I would like to point out at this point is that there's a button to the right, a drop-down that says surface at this point. You can change that to surface with edges to actually see the computational mesh. So these are the cells that we run our computation on. And the other thing that I would like to point out is that we ran a time-dependent simulation. So if you look at the time bar at the top here, we're currently at time 0 of 119 time steps. And so I can move forward in time, I can move backward in time, or I can hit play, and hopefully you can see that I have an animation play until I reach the end at time step 119. So this is how the solution looks at the end. And I can also look at other quantities. For example, the velocity magnitude. That's the velocity magnitude here. Okay. There's a lot more options here inside ParaView. I'm not going to go into all of them, but to show you, this is a source. And then what people typically do is that they apply filters on top of this to visualize certain things. And then these also appear here. And here is the window with all the options. So here you can change, for example, if I wanted to change the edge color for the mesh to black, then I probably cannot see the difference. Let me pick an ugly purple so you can see the mesh in purple, for example. And there's many other options. Yeah. Okay, let me go back to the slides. We talked about this, these steps here. And we talked about time dependence and running and so on. And the next thing I'm going to show you is how to visualize particles. But before I do this, you see that at the very end, the last couple of time steps, I'm clicking through the last 20 time steps, you'll see that the solution doesn't change anymore, right? So we are at a steady state in the sense of that the solution does not change anymore, but we are not at a state where no material is flowing. And you can see this, for example, by looking at the velocity magnitude, right? So there is a flow, but the structure of the flow is no longer changing. And maybe as a bonus, I try to show you the velocity arrows. So I can click on glyph. It automatically, hopefully, no, it does not. So I can pick velocity as the scalar. I can hit apply and it doesn't work. Great. I need to scale by vector. And for some reason it's not working. Excellent. So maybe I'm not showing you glyphs right now.
In this version of ParaView, the sampling of vectors doesn't work unless you set the glyph mode to something else than uniform spatial distribution.
Even all points doesn't seem to work.
Okay.
The scaling. You have to reset the scaling. I don't know why. So this is the velocity field. So let me start from the beginning. This is how the flow looks like, and it reaches a steady state where the solution doesn't change anymore from step to step, but obviously material is still flowing, right? And let me hide this. There's a little I button where you can hide this. What I'm going to show you is I'm going to load particles. In the same folder, there's a file called particles PVD. And if you open that one and hit apply, you will see randomly placed dots on your screen. These are tracer particles that we also put into the flow at time step 0. And if I run, you see how they're being advected with the solution. And you can see, even though in the last couple of time steps where the temperature distribution doesn't change anymore, there's obviously still advection going on. And you can see material rising in the plume and then advecting downwards on the right side of the screen. So this is rather neat to visualize things. And with the particles, I can also visualize them, for example, by ID. That's not really visible very well here. But we can later on talk about attaching properties to particles where you can actually see things or actually have them interact with things. But for now, let's leave it this way. Okay. So I talked about visualizing the temperature. I talked about visualizing the particles. And I showed you how the temperature looks, or how the particles get advected and how it looks like. So before we go into a break, if there are any quick questions I can try to answer, I will do this. The short summary of what I did was clone the repository, go into the folder, run aspect, and then I opened the log.txt and the solution PVD in ParaView to look at the output. Try to find the chat window. Yes, so glyph is a filter which you can find as a globe, or you can find it under all filters. And yeah, maybe I should show you again. The glyph, I'll delete it again. So you highlight solution, you click glyph, or you do filters, alphabetical, and you find glyph somewhere here, there. And then you will have to select the source of the glyph, which is the vector velocity. And when you do this, it's still not visible, but you have to scale mode vector, reset scaling, apply. That still doesn't work. And you have to select all points and apply, and then it's visible. So sorry, I originally wasn't planning to cover how to show these, and I haven't tried it out beforehand. So there's a scale factor, and I had to rescale it. And the reason that I had to rescale it is that ParaView here, for some reason, doesn't get that our geometry is quite large. And just for your information, there's an information panel here that you can click on. And here you can see properties that you have. For example, you see that we have 8,000 cells. And you can also see that if you scroll down, that your bounds here for X range are 10 to the 6, because we do our computation in real units, and we want it several kilometers big. So yeah, scale mode, vector, and then reset the scale. And with that, I can also make the arrow smaller or bigger. Okay. I would encourage you, we may take a short break, and I'll encourage you to play with this and try to get to the same point. And you can already look into the tutorial.prm. That's a text file you can open. I will open that here as well for example, by double-clicking the tutorial.py. All right.
How much of a break do you want to take?
Let's say that we start again at 15 past the hour for all normal time zones and 45 minutes past the hour in India.
Okay, sounds good.